This video will discuss sampling distributions. Sampling distributions will lead us to inference. A sampling distribution is the probability distribution of a sample statistic that is formed when samples of size n are repeatedly taken from the population. In this case, we're going to focus on the sample statistic called the sample mean. So our sampling distributions will focus on what we call the sample mean. And I'll give you an example of what this actually means. So let's look at an example. Let's look at a population of 4 numbers. The numbers 1, 3, 5, and 7. And what we're going to do is sample these numbers in such a way till we take 2 numbers out of a population. So you can think about the numbers 1, 3, 5, and 7 on a sheet of paper and putting them into a bag. And we're going to shake that bag up really well. And then we're going to draw 2 numbers out of that bag randomly. But we're also going to draw, we're going to draw 1, put it back in, and then draw again. So we're going to draw with replacement here. And so here's what happens. When you draw with replacement, if you look here, I give you all the possible samples that can be created. For instance, the smallest sample that can be created is if you draw 1 first, put it back in, and then draw it again. You get a sample of, and we're going to calculate the sample mean between those 2 numbers. So we're going to calculate 1 plus 1, that's equal to 2. But we have 2 numbers, so we're going to divide 2 by 2, and we get a sample mean of 1. Next step we can take is take out a 1, put it back in, then you take out a 3. So 1 plus 3 is 4, divided by 2 is 2. The next one, 1 plus 5 is 6. 6 divided by 2 is 3. The next one, take out a 1, put it back in, then draw 7. 1 plus 7 is 8. 8 divided by 2 is 4. These are all the possible samples where the 1 leads first and a sample size of size 2. The next we can take where all the 3s lead first. And when the 3s lead first, here's what we're going to get. We're going to get the numbers 3 and 1 is 4. 4 divided by 2 is 2. 3 and 3 is 6. 6 divided by 2 is 3. 3 and 5 is 8. 8 divided by 2 is 4. 3 and 7 is 10. 10 divided by 2 is 5. Those are all possible samples where 3 leads. We can do it where 5 leads, and when 5 leads, you're going to get this here. 5 and 1 is 6 divided by 2 is 3. 5 and 3 will give you an average of 4. 5 and 5 gives an average of 5. 5 and 7 is an average of 6. Those are all the possible samples where 5 leads. And then the last one were all the possible samples where 7 leads. 7 and 1 is 8. 8 divided by 1 is 8 divided by 2, is 4. 7 and 3 is 10 divided by 2 is 5. 7 and 5 is 12 divided by 2 is 6. And 7 divided by 7 is 7. It's 14. 14 divided by 2 is 7. So what's going to happen is I'm going to create a graph. Let's create a dot plot for this, for all these sample means. So I'm interested in all the sample means here and all the sample means here. I'm going to plot those on a dot plot. The smallest sample mean here is 1. The largest is 7. So we'll put those numbers on a dot plot. And here's what we're going to have. I'm going to draw X bars over here to let you know that we're talking about the sample mean. And recall the sample mean is called X bar. So we're looking at the X bars. These are all X bars. So we have 1 X bar at 1. Then we have 2 at 2. We have 3 at 3. We have 4 at 4. We have 3 at 5. 3 at 6. 2 at 6. And then 1 at 7. And notice, what I'm really interested in is the shape of the distribution. The shape of the distribution is going to be approximately normal. And I'm interested in where does the mean sit at in a normal distribution. We know the mean sits at the center. And the mean of this distribution is sitting somewhere here in the middle. We know that from the shape. We can actually calculate that if you add up all of these X bars. So you add up, for instance, 1 plus 2 plus 3 plus 4 plus 2 plus 3 plus 4 plus 5 plus 3, plus 4, plus 5, plus 6, plus 4, plus 5, plus 6, plus 7. If you add up all those, here's what you're going to get. We call it the sum of the x bars. So adding up all the sum of the x bars gives you a value of 64. There's a total of 16 x bars here. There's a total of 16 of these values here. There's 8 right here, and then 8 right here. It's a total of 16. So we'll divide that by 16. 64 divided by 16 is also 4. So we call that the mean. This is the mean of the x bars. The mean of the x bars was equal to 64 divided by 16, which is 4. Now, look at these are your x's right here. These are the x's. Let's calculate the mu of the x's. That's 1 plus 3 plus 5 plus 7. So that's 4 plus 5, which is 9, plus 7, which is 16. That's 16 divided by 4, which is also 4. Look what happened here. The mean of the x bars is 4. The mean of the x's from the population was also 4. This is not a coincidence. And this is going to lead us to the first property of a sampling distribution, which says this. The mean of the x bars is equal to the mean of the x's. This is good news because generally speaking, we don't know the mean of the population. So how can we estimate the mean of the population? Well, we can use the mean of a sample to actually estimate it. That's what this is saying. The other property that's going to come from it is that the standard deviation of the x bars. So again, if we go back and we look at all those values again, and we find their standard deviation, it's going to be equal to the standard deviation of the x's divided by the square root of n. In this case, our n was 2. We looked at sample sizes of size 2. So we divide that by the square root of 2, and we're going to get the same value. This value right here, the standard deviation of the sample statistic, the standard deviation of the sample statistic is known as a standard error. So that value is called the standard error.